Hello everyone, I'm Mingyu John, the team lead of this project. I'm so glad to introduce Parallel-structed blockchain for scalability and stability through Klaytn improvement ledger. Now I start to introduce this interesting project. The presentation will proceed in the following order. Moving from single-core CPU to multi-core CPU, we have been able to use extremely high-speed computers and live a comfortable and innovative life. Blockchain can also challenge multiple blockchains beyond its limit. Hello Blockchain, our project, is a technology to increase scalability and stability. Expect scalability from 4000 TPS to 8000 TPS, and fault tolerance to improve by an average of about 20 times. The biggest characteristic of a parallel blockchain is that one Klaytn core and one Klaytn council are divided into two, and block generation and consensus are carried out separately. We have seen the necessity and feasibility of parallel blockchain through many previous team researches. I thought that Klaytn, an enterprise blockchain, is the best fit for parallel blockchain's greatest strengths, scalability, and stability. So we applied to KIR to materialize and develop this project to contribute to the Klaytn ecosystem. This team consists of one blockchain researcher and one computer science professor who majored in algorithm. Mingyu John, the team lead, is blockchain researcher at Sungsil University, and he plans to start a blockchain game startup soon. Mingyu John leads the overall research of the project, including the design and development of the project. Hyun-Soo Na is professor at Sungsil University. She is major in computational geography and algorithm. Hyun-Soo Na participated in project design and especially deals with algorithm analysis of consensus algorithm in depth. And we plan to recruit one more researcher. Since we have been conducting joint research for 2019 to present to many projects listed in slide, we can proceed quickly with accurate and logical decision making. Through several studies, we have come to the conclusion that the popularization of a blockchain is not far off, and blockchain with excellent scalability and stability are necessary to popularization. Several statistics support our claim. In the DM market, after the blockchain boom in 2017 and 2018, the number of DApps is rapidly increasing again in June 2021. The difference at this point is that the system recognizes cryptocurrency and blockchain, and the existing Web2 players are declaring their participation in the market or the Web3 with blockchain at the forefront. This is that the inflowing of existing Web2 users can use blockchain quickly, and the number of transactions occurring on the blockchain platform along with the number of new DApps can rise rapidly. It can be seen that more transactions are occurring at this time than when the number of new DApps surged in 2017-2018. This means that the previously developed DApps are being used steadily and that the range of transactions that can be done in a single DApp has been expanded. In the future, the service will continue to add more actions to the blockchain, and users will be able to use more destructive and innovative services. Considering that the number of new DApps is rapidly increasing and existing Web2 players are entering, and the action within blockchain are rapidly increasing, then the number of blockchain transactions is expected to increase rapidly. Klaytn has advanced technological technologically to the level that can be used in real life as more advanced blockchain than Bitcoin, Ethereum, and EOS. In particular, it has made a lot of progress in scalability. Due to this scalability, it can be a good option for BFs take full advantage of Klaytn's fast speed and service that want to add blockchain advantage to commercialized services. Based on blockchain scanners, we can find out more depth in Ethereum, but more transactions in Klaytn. It can be predicted that Klaytn is mainly used by BFs that are more actively required for smart contracts. As the blockchain ecosystem continues to grow, Klaytn's current TPS is expected to rise faster than Ethereum. In particular, as Web2 players enter the market, the number of transactions in Klaytn is expected to surge. Klaytn has a good performance of max 4000 TPS, but considering its growth, it is necessary to increase the capability of Klaytn's max TPS. I would like to add a suggestion for the possibility of technological improvement in Klaytn following the need according to the market change. The two things, scalability and stability. First, scalability. As the current TPS rise, the cost to performance limit is reached, leaving only services that can afford the cost. This minimizes the introduction of blockchain or greatly increase the barrier to entry by causing an increase in service operating cost and operational uncertainty of companies. For a sustainable blockchain, it is necessary to preemptively solve the cost to performance limit of the blockchain. So we propose 8,000 max TPS. Second, stability. Klaytn encountered a major technical problem, blockchain suspension, twice. This greatly increased the barrier to entry by causing operational uncertainty of companies. Operational stability of blockchain is directly related to technical reliability. Several safeguards should be put in place for the growth of the network and the restoration of technical trust. So we designed a parallel blockchain with fault tolerance that allow the remaining blockchains to process transactions even if one blockchain network is stopped. If a problem occurs, performance may decrease from 8,000 TPS to 4,000 TPS, but the probability that entire network will stop for a long time is about 20 times lower. In specific, assume the success rate of consensus of existing blockchain is 95% of 4,000 TPS. The parallel blockchain is guaranteed 90.25% of max 8,000 TPS and 99.75% probability of max 4,000 TPS. Now I introduce project briefly. The purpose of this project is to improve the TPS and fault tolerance of the Klaytn blockchain through the introduction of a parallel blockchain structure. It described the consensus algorithm, consensus council structure, and council swapping, blockhead, and storage methods that change according to the introduction of the parallel blockchain structure. The optimized consensus algorithm is described in pseudocode form, and the complexity of the algorithm is calculated to estimate the max TPS according to algorithm complexity calculation result. In addition, we develop a parallel blockchain in a single form and compare it with the max TPS estimate through the testing. In a parallel blockchain, two different blockchains communicate and operate as one blockchain. When blocks of each blockchain are created, the previous block hash of the blockchain being created and the latest confirmed block hash of other blockchain are referenced. In the Istanbul PBFT, the block generation time of 1 second is maintained in order to minimize the inefficiency of TPS through the timeout situation, and to utilize the stability of the existing Klaytn's well-designed Istanbul PBFT. It is parallelized by referring to the idea of sharding, but because it consists only of reliable nodes, it has a completely separate and a parallel structure, not only the processing of transactions. Blocks are generated in a round robin, as shown in figure above slide. Technically, each block's creation time is 1 second, but when viewed from the user's point of view, it is 0.5 seconds. Max TPS is proportional to block generation intervals and block size. Therefore, the max TPS is expected to be 8,000 TPS, which is twice the 4,000 TPS. In a parallel blockchain, the block DB that stores the block information only need to store the block information of the own blockchain. The reason for sharing the state DB is to minimize communication between blockchains. It deals with the changing consensus algorithm by introducing a parallel blockchain. Each blockchain individually proceeds with consensus according to each block generation time. The consensus algorithm retains the structure of IBFT as it is. As the consensus proceeds independently, more transactions can be included in a block faster, resulting in an improvement in scalability. As the CNN is divided into two, a process is added to continuously maintain the logical centralization of the blockchain. In accordance with structure change, we add a sync receipt and receipt verification stage. You can find out stage of modified IBFT in Progress Technical Report 1. Because of parallel characteristics, parallel blockchain can get a great improvement in fault tolerance like this chart. By referring to the study on probability on failure in PBFT, it is possible to study probability of reaching consensus when switching to a parallel blockchain. If success rate of consensus of the PBFT blockchain is 95%, success rate of the consensus of the parallel blockchain is 99.75%, 20 times improvement in a failure rate. Through this research, we can contribute to three groups in Klaytn. First group, users. Scalability allows users to work around the cost to performance limitations, so the date of increase in transaction gas fee is delayed. Stability can give users higher technical reliability, lower operational uncertainty. Second group council. Klaytn will be more stable blockchains through parallel blockchain. Barrier losses can be prevented because of blockchain suspension. For example, block reward 345,600 clay. It is about $580,400 and transaction fees that cannot be obtained during the network failure period. It is about 10 hours. And more max TPS allows more BS, more transactions in the same time. Third group, community. I believe that a lot of research is to design new technologies and show them possibility and example to the world. Secure a single sharing path by creating a project web page and share research on the para-blockchain structure through various channels. For example, domestic and international academy, design failure bounty. A lot of interest from the community through active sharing of results and many additional research opportunities through proposal of new possibility can help Klaytn's research ecosystem virtuous cycle as a result. The milestone and schedule. We already did 3 months research and we made progress technical report 0. Progress technical report 0 is submitted along with this proposal to support KIR governance in-depth review of the research goal achievement and the possibility of successful research. Progress technical report 0 include market analysis on Klaytn, economic effect analysis of research, prior research, parallel blockchain structure, block information, and consensus algorithm design. With the support of KIR, we will finish the design in 4 months and achieve results such as algorithm analysis, prototype development, testing, community activities, and submission of paper to international journal in 4 months. The key deliverables. A test report and an algorithm analysis report are added to the progress report. A budget that is too low causes a contraction of the market for KIR, and a budget that is too high causes abuse. So we prioritize rational budgeting according to the value of a project. According to effect analysis in Progress Technical Report 0, the economic value provided was briefly analyzed, and a reasonable budget was established to maximize the effect of project accordingly. Design failure bounty is a system that allows design errors to be verified by community and has been added to bring community interest in research. You can find our progress report 0 through this link. Thank you for listening presentation. Any inquiries can be made through the email address on the first page.